paper out, I'm starting my notes. You're either with me or you're not. All right, we are solving by factoring. We are solving by factoring. In an example 1, our problem is already factored for us. Sometimes we'll have to factor. Sometimes the problem will already be factored for us. So I know the problem is factored because I have 2x on the outside and I have x minus 7 on the inside. Looks like they went ahead and factored out the greatest common factor. So if you have an equation and one side of your equation is factored and the other side is set equal to 0, we have this thing called the multiplicity property of 0, and it says if two things multiply to be 0, and those two things are 2x and x minus 7, if two things multiply to be 0, then those two things have to be equal to 0. So that means that 2x would have to equal 0, and x minus 7 would be equal to 0. So we have a rule in mathematics that says if two things multiply to be 0, or if more than two things multiply to be 0, then each one of those things has to be equal to 0 itself. And that gives you two little equations, 2x equals 0. You would divide both sides by 2 for the first equation, and 0 divided by 2 would give you 0. So one of your solutions is 0. And then you would add 7 to both sides, and you would get x is equal to 7, and those would be your two solutions. And if you put them back into the original equation, 2 times 0 minus 7, that would give you 0. If you plugged a 7 back in, 2 times 7 minus 7 minus 7, that would give you 0 also. So we're solving equations here using factors, two things that are multiplied together to set equal to 0. All right, any questions about example 1? Same thing going on in example 2, except the factors are a little bit more complicated. Everybody got example 1? All right, example 2. The problem's already been factored for us. We have 5x minus 5 times 2y plus 6 is equal to 0. 5y minus 5 times 2y plus 6 is equal to 0. So again, we can use that rule that says anytime two or more things are multiplied together and set equal to 0, then each one of those things, those are factors, have to be equal to 0 themselves. So you set 5y minus 5 equal to 0, and you set 2y plus 6 equal to 0, and that gives you two little equations to solve. So if you have 5y minus 5 equals 0, you're going to add 5 to both sides. That's going to give you 5y is equal to 5.
You divide 5 by each side.
Then you're going to divide both sides by 5, and one of your answers is going to be 1. On the second equation, you're going to subtract 6. You're going to get 2y is equal to negative 6. You're going to divide both sides by positive 2.
Negative 3.
And your second answer is going to come out to be negative 3. Alright, so my first two examples are showing you when the equation has already been factored. Already factored. Okay, my example 3 is going to show you when the problem is not factored to begin with. So let's look at example 3. So I have a couple things going on in example 3. The first thing that I notice is I don't see that one side is set equal to 0. In this equation, the left-hand side is x squared and the right-hand side is negative 2x. Okay, I don't have any factors, and I also don't have one side of the equation that is set equal to 0. So which exponent has the highest, which term has the highest exponent? X to the second. You always want to move everything to the side of the equation where your highest exponent term is positive. So we're going to want to move that negative 2x. We're going to want to move it over to the left-hand side. So we're going to add 2x to both sides. We're going to get x squared plus 2x. And then the right-hand side is going to go to 0. Okay, as soon as one side of your equation is 0, it can be the left-hand side or the right-hand side. It doesn't matter. go look at the opposite side and ask yourself, is it factored? Is x squared plus 2x factored? Can you factor it in any way that we have discussed? Is there a GCF? Is this grouping? Is it a trinomial? It has a GCF. What is the GCF between x squared and 2x? Just x.
Oh,
Okay? So we're factoring out the GCF of x. X times what is x squared? X times what is 2x? Plus 2. So now we have our factors. One factor is just the x. The other factor is x plus 2. When two or more things multiply to be 0, then those things have to be equal to 0 themselves. So your GCF, you said equal to 0, and that's already solved. So one of your answers is 0, and then you set the x plus 2 equal to 0 and solve that little equation, and that tells you that your second answer is negative 2. So in example 3, two things were going on. One side of the equation was not equal to 0 yet, and once I made one side equal to 0, I had to factor the other side before I could set each factor equal to 0. I have two more examples for you. Example 4. X squared minus 7x plus 12 is equal to 0. The good thing is there's already the 0. Okay? The good thing is that there's already a 0 on one side. The bad thing is that the opposite side is not factored. We're going to solve once we factor, but we have to factor first. So is there a GCF between x squared, 7x, and 12? Okay, if it's just 1, then it's not going to do anything if you factor out a 1. It won't change the problem at all. But this is a trinomial, right?
yeah.
And don't y'all know how to factor trinomials? Yep, they factor into two binomials. Okay, Victoria's already got it. It's x and x. Are the signs plus plus, minus minus, or opposite? They're minus minus. And Victoria's already figured out what multiplies to be 12 and combines to be 7 is 3 and 4. So now we have our factors. So we have x minus 3 times x minus 4 equals 0. That means that x minus 3 could be equal to 0, and it also means that x minus 4 could be equal to 0. Anything that multiplies to be 0 could be equal to 0 itself. So that's going to give me positive 3
X plus 4.
and positive 4. Alright, how could these problems get harder? They could get harder when the number like 12 is a bigger number. Y'all know that. If you're trying to factor and you're having to look for all these factors, so the last example that I have has a pretty big number in it in the place of the 12. So example 5 is our last example. Everybody got 4? Everybody got 4? Alright, last one. Example 5. Y squared minus 90 is equal to 13y. Y squared minus 90 is equal to 13y. Alright, you tell me what to do. I've given you an example of every possible situation, so y'all tell me. Yeah, we want to move everything over to the side where the y squared is positive. So let's subtract 13y. Should we put the left-hand side in any specific order? Standard. Good job. So standard would be y squared minus 13y minus 90 is equal to 0. I chose this one. I chose the 90 so you would have a little bit harder time because some of these can get a little bit hard. So we're looking for two numbers that multiply to be 90 that add to be 13 or that subtract to be 13. Subtract because the 90 is negative. So let's go ahead and put y plus and y minus, and you might have to use your calculator on this. So we know that some factors of 90 are 1 and 90. Help me out. Let's go in order. 1 and 90. 2 and 45. If you don't know, just use your calculator. Will 3 go into 90?
3 and 30.
3 and 30.
45.
2 times 45 is 90.
5 and 18.
5 and 18. Okay. Do you see anything yet that subtracts to be 13?
5 and 18.
5 and 18. So 90 was pretty big. You might have had to use your calculators to find some of your factors. Now you've got to decide which one is positive and which number is negative.
18 is positive, 5 negative.
18 is negative. You got to get a negative 13y. Now, in order to do that, your 18 needs to be negative and your 5 needs to be
Positive.
positive. Does that make sense? Okay. So now you take your y plus 5 and you set it equal to what? 0. And you take your y minus 18 and you set it equal to 0, and you solve your two little equations there. And you'll get your solutions. So I'm getting negative 5 and positive
18.
18.